Welcome to your Getting Started with Python class, Skillcrusher. My name is Lex, and I'll be here by your side throughout this class as you build and expand your Python coding skills. To start, let's dive into what Python is and why it's awesome. Python is an incredibly popular and versatile coding language that was developed by Guido van Rossum and first released in 1991. Van Rossum designed Python based on the philosophy that a coding language should be readable. This means that Python is easier to learn and work with than many other coding languages out there. And here's a fun fact. It's named after the British comedy troupe Monty Python. Aside from its readability, what else makes Python awesome? Well, Python is a general-purpose language, meaning it can be used for many different things, including 1. Web development, 2. Data analysis, 3. Machine learning, 4. Game programming, and 5. File processing. Learning Python opens the doors to so many fields. Isn't it amazing? Here at Skillcrush, you'll be focusing on the web development, data analysis, and file processing applications of Python. Python is also open source, which means anyone can use the code for personal and professional projects. And because Python is open source, there's a huge community of like-minded coders who are able to create new tools and functionality for it. Now, before you dive into writing Python code, you'll need to know some basic foundations of computational thinking. Computers think differently than people. They use math and logic to solve problems and only think in zeros and ones. Computers also love simplicity. While computers appear to be capable of handling complex problems, they actually need their instructions to be simple and straightforward. Computational thinking is the way computers think and solve problems through code, a vital skill all computer coders use daily. There are 4 principles of computational thinking. 1. Decomposition. 2. Pattern recognition. 3. Abstraction. And 4. Algorithm writing. Decomposition is the process of taking a large problem and breaking it down into smaller problems that are easier to solve. For example, think about folding a big pile of laundry. At first, it feels overwhelming, but you can actually use decomposition to see that a pile of laundry is just lots of small problems that need to be solved. Pattern recognition is about looking for similarities among the smaller problems you identified in the decomposition step. Identifying patterns can help you come up with a single solution to solve many problems at once. Back to the laundry example. After you've folded the laundry, you need to put it away. By recognizing the patterns, all towels in one pile, all clothes in another, you can put away similar items at the same time, which creates less work than putting them away piece by piece. Abstraction is finding a simplified version of the problem to solve and ignoring the extra details. Let's say you're looking to buy a new car. Abstraction allows you to focus your search on the most important car features, like price and number of doors, and ignore less important details like wheel size and interior color. Finally, algorithm writing is creating the instructions or code the computer will follow in order to solve the problem and make something new. In real life, you create algorithms when teaching your dog a new trick or giving driving directions to a friend. In this class, you'll get lots of practice using computational thinking to create impressive Python projects for your portfolio, including your class project, a personal assistant app. Your personal assistant will help you recall important birthdays, create a to-do list, and even manage your personal contacts. When good help is hard to find, why not just code your own? Now, it's time to start on your journey with Python, and I'm so excited to see all the code and projects you'll finish along the way. Click Next to get moving.